Okay, and here we are back at it again with lesson 12. I do realize that at the end of the lesson 11 video, I forgot to give the practice and the homework. So really quickly, turn to the practice section of lesson 11. Number 1 through 13 is your practice. 1 through 13 is practice. Number 14, 16, and 17 are your homework. Homework is only 3 questions, 14, 16, and 17. If you turn one more page, the remember section, as usual, is extra credit. Okay. 1 through 13 is practice. 14, 16, 17 is homework. Remember is extra credit. Now, we're on lesson 12. For lesson 12, I do recognize not everybody has a calculator. It's okay. I'm going to show you what you need to do as we go. I'm going to try to show you via my calculator on my iPad. That's where I'm recording this from. But first things first, we got the warm-up. For lesson 12, we are... Sorry, just rummaging through some pages here. Excuse me. For lesson 12, we're doing operations with numbers in scientific notation. Our objective is to interpret numbers in scientific notation displayed on digital devices. All that means is we're doing scientific notation on a calculator and getting familiarized with that. And then we're going to operate with numbers written in scientific notation. All that means is we're going to add, subtract, multiply, divide. Basic stuff, basic mathematics. That's all that means. Now, to the warm-up. For the warm-up, the instructions say to write each number in scientific notation. I gave you the first two. Number 1 gives us 56,000. Let me go to my annotate here. 56,000, this is a large number. Write that down somewhere, large number. Because this is large, that means we have an invisible decimal place. Let me zoom in a little bit. An invisible decimal place there at the end of the number. And we're going to have to carry our decimal place over to the last number that is in between 1 and 9.99. And we're going to carry it over to the left. Counting. 1, 2, 3, 4. That's our new decimal point. That gives us 5.6. Annotate how many jumps you took. In this case, it was 4. Okay, so our answer for that is 5.6 times 10 to the positive 4. For number 2, once again, we just practiced this in lesson 11, making small decimal numbers and turning it into scientific notation. From our decimal point, we're going to move to the right. 1, 2, 3, 4. That's our new decimal space right there. And because we moved to the right for a small decimal number, our exponent here, or our order of magnitude, is going to be a negative 4. Okay? I'm going to leave you to do, undo. I'm going to leave you to do 3, 4, 5, and 6 on your own. Pause the video here to allow time for warm-up. After warm-up, come back. Moving on. I'm just going to read this off. This is number 1 in our lesson. Liam enters 200,000 times 450,000 into his calculator. The screen shows the following display. It gives 9e plus 10. The instructions say to calculate 200,000 times 450,000 by writing the numbers in scientific notation. Underline that. In scientific notation. Put a star by this calculator value here. The reason why I'm having you star this is because that E, which typically would be capitalized, but sometimes depending on what type of calculator you're working with, it may be lowercase. That E, somewhere at the top of your paper, write this. E means times 10 to the nth power. That's what that E means. So if I put a number E, like how it says 9E up here, that 9 with that E attached to it means times 10 to the power of, and this exponent here, this plus 10, that's the exponent, positive 10. Okay, so E on a calculator means that you're multiplying something to the power of 10 and it's going to be raised to some exponent. The number at the front here, this 9, is your A value. E is times 10. This number on the end in the box is the exponent. If it helps, you can line it up with the original scientific notation formula, just to make it make sense for yourself, which is A times 10 to the nth. Let me use a different color. Zoom in. This 9 will be our A value. This E, that's the times 10. And this positive 10 on the end is the exponent. Just like that. Now, if I had to put this back in scientific notation, if you paid attention, we already did. That's this 9 times 10 to the power of 10. So just rewrite that as your answer. 9 times 10 to the positive 10. In a minute, I believe I will get the chance to plug that in, but for the time being, we're moving on. If you hear me rummaging through some papers, I'm just making sure I'm keeping track with what I wanted to get through with you guys. Here, raising powers to a power. Remember we did that already with those formulas that we put in the table? We're back at it again. I'm just read off the instructions right quick. Problems 2 through 6. Use the properties of exponents. Underline that, because that refers to those tables. So if you need to reference those tables, I believe it was on page 81, feel free to reference those formulas I gave you. Use the properties of exponents to evaluate the expression. Write the answer in scientific notation. Underline that. Because if the answer is in something other than scientific notation, it is incorrect. Check the answer with a calculator, which I will do on my end. For number 2, it gives us 3.72 times 10 raised to the 5th power, raised again, squared. Okay, so 3.72 times 10 to the 5th squared. Now, typically, if I just wanted you to write this out right quick, I want you to write 3.72 squared, because that has an invisible power 1 over it, like any other number or variable. Make my decimal a little darker. That's a terrible decimal, but y'all know what it is. Times 10. We multiply that outside exponent to the inside exponents. 5 times 2 is 10. That gives us 3.72 squared times 10 to the 10th power. But I don't want you to leave this exponent here. This is why we're going to plug it into a calculator. All right. This is what it looks like in a calculator. Here we go. So if I put, matter of fact, just for the sake of viewing, I'm going to write the whole original problem. Times 10 to the power of 5. Raise again to the power of 2. Now that is a very large number. Okay? So I'm going to remix this a little bit. If your calculator gives you something like that, here's a second way to write it. Okay? Ooh. We're going to keep this 3.72 squared, and we're going to take this times 10, and we're going to use E. Okay? Now, E on here says exponent down here at the bottom, EXP in all caps. That means the same thing. Let me make sure I'm in degrees. So we got 3.72 squared, and I'm just plugging in. And I really don't have to put times exponent. Matter of fact, I'm going to go ahead and square it. Exponent. Our exponent was 10. All I'm doing is plugging in. This 13.8384, that is 3.72 squared, calculated. After I calculated it, I multiplied it by the power of 10 by pressing exponent down here at the bottom, which typically would be an E. But on this calculator, it's labeled as EXP in all caps. Okay? And then I included the power, our N value that it's raised to, which was 10. Okay? Equal. We get the same number again. It's okay. All that means is this calculator it has too much space for us to be able to get what I'm looking for. So instead, we're just going to count zeros. I'm sorry, we're going to count decimal places. Excuse me. So, us moving from right to left, from that last zero down to that 1 in the 3, in between that 1 and the 3, that's where we're going. Counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 decimal places. And I'm just going to round this down a little bit. Better yet, I'm going to round it up to 1.38 because we don't need the whole decimal. In the calculator, that gives us 1.38 times 10 to the 11th power. Okay? Sometimes when you calculate certain numbers, let me see if it'll do it for number 1. It probably won't. But sometimes when you put really large numbers in a calculator, it'll give you that E on its own, and you'll just have to interpret. Like if I did this number times a billion, let's just say. See, 100, 100,000, 100 million, billion. There we go. Excuse me. That gives us 1.38384 E times E. That means times 10 to the power of something. And that something would be this plus 20. So that 1.38 is our A value. The E in the middle means times 10. This plus 20 is the exponent it's going to be raised to. So the answer for this would be 1.38 times 10 to the 20. Okay? That's what I was looking for. That's what I want to show y'all. Make sure you have your answer for number 2. It was 1.38 times 10 to the 11. Don't accidentally write the other answer. I just did that for demonstration. For number 3, we have 4 times 10 to the 6th power squared. I'm going to just do that whole thing in the calculator. And we'll see what it gives us. Parentheses, 4. And I could put times 10 to the power of blah, blah, blah. But just to shorten that up, I'm going to go ahead and I'm going to hit EXP down there. Because that means times 10 to whatever power. In this case, it is 6. Close the parentheses. Hit that X with the Y exponent button to raise it to another power again. And we're going to raise it to the power of 2. Equals 1.6 E. That E means times 10 to the power of 13. Okay? 1.6 times 10 to the power of 13. That is how you do it in the calculator. And I'm just writing it out here Now, if you wrote 1.6 E 13, I know what you're talking about, but I'd rather you keep it this way. This is scientific notation here. This is a calculator version. I don't want that on paper. That's just for you to know. You just need to know what that E means. E, equate that to multiplying something to the power of 10. Okay? Now, number 4, 5, and 6, I'll let you guys do that in your own time. And just leave that as some independent practice when you have free time. To warm up to it, we're going to move on a little bit to number 7. I'm going to just read the instructions for problem 7 through 13. Use the values from the table to answer the questions. Write the answers in scientific notation. Use a calculator to check your answers. Okay, so we have some measurements here of some animals and some various objects and so on and so forth. And I'm just going to do a few of these. For number 7, it says, about how much longer is the state of California than the state of Rhode Island? Okay, so I'm going to just scroll up right quick. The state of California is right here. And the state of Rhode Island is here. Just mark that somewhere so you don't get confused. And it's asking how much longer is the states, or how much longer than. Make a note here. If you see how much longer, that typically means to subtract. You're going to be subtracting. And you're going to subtract the length of Rhode Island from the length of California. I'm going to just write out the equation here. The length of California, make sure you put it in parentheses, is 1.25 times 10 to the power of 6 minus the length of Rhode Island, which is 7.7 times 10 to the power of 4 equals. Now, we can do a bunch of mathematics and try to calculate this on paper, but just for the sake of time and for the sake of demonstration, I'm going to do it on a calculator. I will give you a quick tip that a simple way to do this would just be to manipulate one of these numbers. Like, you can manipulate the length of California and drag this decimal place back to the left a couple of times, make it smaller. That way our exponent will be 4. Or you can make the 7.7 for the length of Rhode Island and drag the decimal place forwards 2 times, and that'll allow you to change the exponent to 6, and then just subtract normally. Okay, but once again, for the sake of demonstration, calculator. Let me clear that off. We got the length of California. I'm just going to put it in 1.25. I'm going to hit that exponent button down here. That means E to the 6 minus the length of Rhode Island is 7.7. I'm going to hit E. That means power of 10 to the 4 equals. We have 1,173,000. Let me see, is it measured in meters? It's measured in meters. Going back into scientific notation, we're just going to count off from that final 0 and move the decimal place to the left. That gives us 1, 2, 3, 4, 5, 6 decimal places that we have to move back. Okay? So on our paper, we're going to put that this equals 1.173 times 10 to the 6. That's how you do it on calculator. All right. Let me see. Let's scroll here. For number 8, It looks confusing. It's actually very simple. It really just wants you to fill in the blanks. But we're not really going to do that. I'm just going to show you another way to solve this problem. Because I've explained this before, and I even just explained it for number 7, but I don't think I've ever demonstrated it. So we're going to do number 8 together. It says about how much longer is a tube of lip balm than the width of a human hair. Okay? And it gives you 6.7 times 10 to the negative 2 minus 8.10 raised to the negative 5 power. If I really wanted to make these exponents equal, all I would have to do is pick a number and move the decimal place either to the left or to the right, and necessary amount of times to make the exponents the same. Like for 6.7 raised to the negative 2 is already raised to the negative 2, but our greatest exponent here is negative 5, or the smallest, better yet, should I say. So if I wanted to get negative 5 here instead of negative 2, take your decimal place and move it to the left, not the right, because that makes it larger, and that'll make your exponent larger and make it positive. We need to keep it negative. Move it over 3 more times. 1, 2, 3. Like that. And then that'll give you 0.0067 times 10 to the negative 5. Okay? And then you'll subtract. Just a little trick, or a little rule of thumb. And you could have done the exact opposite as well for this 8 times 10 to the negative 5 and just made that smaller by dragging the decimal point forward. Just a trick. We're going to skip past number 9. We're going to skip past number 10 because those are still subtraction, but we will do number 11. If you can remember, back for topic A, make sure you annotate when you see how many times. That means you're going to divide. That's giving you the operation right there. Anytime you see that, write divide. Number 11 says a blue whale is about how many times as long as a tube of lip balm? If you reference the table, which I'm doing in real time, a blue whale is measured at 2.8 times 10. And that's it. 2.8 times 10. If it bothers you that it doesn't have an exponent over it, just write a 1. It means the same thing. Okay? And the measurement of a tube of lip balm, that's what we're dividing by, is 6.7 times 10 to the negative 2. If this looks like a lot of numbers for you, just put it in parentheses to help you to break it up. Trying to make my decimals a little more apparent, but they're coming out raggedy. Excuse me, sorry. Once again, in the calculator, just for practice. Go back to it. We have 2.8 times 10. Gonna hit that E button again, to the power of 1, divided by a tube of lipstick, or lip balm better yet, is 6.7. Gonna hit that E again. That means times 10 to the power of negative 2. Yes, you can put negative exponents in the calculator. It'll still come out correct. Equals. We have 417.91, and I'm going to just round that off a little bit because we don't need all 15 of the numbers after the decimal. So we're going to keep that 417.91. 417.91. 0.91. Now, this is not in scientific notation. Our answers have to be in scientific notation as it's stated in the directions. So don't just write 417.91. Put it back in scientific notation. Write your formula. Okay? A can't be greater than 9.99, but it can't be less than 1, so we just going to carry it over 2 times to the left. 1, 2. That'll give us 4.1791 times 10 squared. That's it. I try to make this as simple as possible for you. I'm going to skip just a little more. I'm going to let you do 12 on your own so you can have some practice with dividing. For 13, it reads, which object from the table is about 50 million times as large as a blue whale? Whenever it gives you a number times something, 50 million times, here you're going to multiply. Annotate that, meaning write that down. You're going to multiply 50 times. So it gives us 50 million times as large as a blue whale. The measurement of a blue whale was 2.8 times 10 to the power of 1. And we're just going to multiply that by 50 million. And I'm going to just write it in because I'm being lazy. 50 mil. Okay? Really, that'll be 5 times 10 to the 7th power. But we know what 50 million looks like because I'm going to put it in the calculator anyways. Back to the calculator. You have 2.8. The measurement of a whale times 10. I'm going to hit that E again to the power of 1. And just for the sake of demonstration, yet again, I'm going to write the whole number 50 million in there. Okay? 50. 1, 2, 3. 50,000. 1, 2, 3. That's 50 million. When you're working with parentheses in a calculator, once you close the parentheses on the end of a number, then open another one, that automatically means to multiply. So you don't have to put times and then start the parentheses again. It knows that you're trying to multiply. Okay? That gives us a very large number that I'm not even going to try to read off. But I will move the decimal place over so we can put this number, this very large number, in scientific notation. This is a very large positive number, so our exponent will stay positive. Okay? From that last 0, moving over to the left, I'm just going to count decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. I stopped in between that 1 and the 4. That gives us 1.4 times 10 to the 9. All right? In scientific notation. 1.4 times 10 to the 9. If you have a calculator to work with, fantastic. If you do not, then I would normally say you can just come to me and I'll help you out, or we can pass a calculator around if we have a few. I'm working on trying to get some for the class, so just have a little patience with me. In the meantime, knock out your exit ticket. Okay? In order to be successful at this exit ticket, you need to know what that E means. All right? You also need to be able to calculate with it. Normally, I would want to do this with you just so you can have that calculation on the board for everybody to see. But since I'm not there, obviously, you'll need to do this independently. So hopefully whoever it is subbing my class will be gracious enough to pull the calculator up on the board for you guys to be able to see and enter whatever integers you need to be able to work with. That is your exit ticket. It's only 2 questions. Make sure you turn in your exit ticket before you leave my room today. Before I go, I'm going to give you your practice. And I'm going to give you your homework. Lesson 12, practice. Just give me 1 second. I'm getting there. Your practice is number 1, 2, 3, and 4 for the practice section. 1, 2, 3, and 4. Your homework is 5 through 10. Okay? So that's 5, 6, 7, 8, 9, 10. All of those have something to do with that table. Make sure that you are annotating, whether you're going to subtract or add or multiply and divide from within the question. They give little cue words and hint words to tell you what kind of operation you're going to be doing. Make sure you're paying heavy attention to those giveaways. That tells you exactly what operation to perform. All right? As usual, your extra credit is the remember section, but I will offer bonus questions. Your bonus questions will be 11, 12, 13, all the way through. But for C, you do not have to do C for 13. And these bonus points are optional. You don't have to do them. If you don't do them, it's okay. It won't count against you. This is just a little extra for those who might want the extra push. So 11, 12, and 13 are bonus, except for C. All right. So remember is your extra credit. Make sure that you gently and neatly rip out your exit tickets before you leave my room and turn them in.